Right, from the Pythagorean theorem, or actually the converse of the Pythagorean theorem, we're able to make some decisions about what type of triangles we have based on the side lengths. Okay, so we know how we get a right triangle with the Pythagorean theorem. If a squared plus b squared is equal to c squared, now again, these are the two shorter sides, and c is the longest side when we do this. If this is the case, we know we have a right triangle because it satisfies the Pythagorean theorem. But it does two more things for us. If we compare them and they're not equal, we know it's not a right triangle, but we can also decide whether it's an obtuse triangle, if it's not right, whether it's obtuse or acute. And we do that using inequalities. Again, when you set this up, you want these two to be your shorter sides, and then the one by itself should be the longest side. Okay. If the longest side squared is greater than, because obtuse means big, right? Bigger than 90. Okay. If it's bigger than the other two sides squared and added together, then you have an obtuse triangle. If, on the other hand, your longest side squared is less than the two sides squared and added together, then that tells you that your angle is smaller than 90 and you have an acute triangle. Okay, so that's how we can tell the difference. We use the inequality. Again, bigger means obtuse, and if it's smaller, it's acute. If it's right on equal, then it's a right triangle. Okay, so here are some examples. So if I had side lengths 3, 4, and 5, okay, here's an example of one that I find out is a right triangle. Okay, so again, you make sure you put the two shortest sides here. Square them each, got 9 and 16, and then add them together. If they're equal to the other side squared, which they were, then it's a right triangle. Here's an example of one that comes out to be obtuse, lengths 2, 4, and 5. Again, you want the two shorter ones by themselves, or together, excuse me. So 2 squared plus 4 squared. And the one that's the largest one over here by itself. Well, 2 squared was 4, 4 squared is 16. 25, my 5 squared, is greater than the 20 I get from adding them together. Since it's greater than, that biggest side is greater than, then I know that this is obtuse. And finally, an acute triangle, lengths 4, 4, and 5. Again, we want the two shorter sides to be alone, squared, and added together. The longest side is solo over here. We compare their sizes. We square and add and get 32 over here. Over here, 5 squared was just 25. Since it's less than the other two combined, it's an acute triangle. Okay, so less than is acute, greater than is obtuse, and right on equal is the Pythagorean theorem. We're going to do some examples. So here's 3 examples. Let's decide if each length of the side below are acute, obtuse, right, or maybe they're not a triangle at all. So we have to check that also. Just really quickly beforehand, make sure that remember our rule that the two shorter sides added have to be longer than the third side in order to be a triangle at all. Check that first. So like for this one, 12, 23, and 14, just double check the two shorter ones would give me 26, which is greater than that third side of 23. So yes, it's going to be a triangle. What kind of triangle? Again, we want to separate out. Here's our two shorter ones. We're going to square those and add them together. And then we're going to decide what are they compared to that third side squared. Okay, less than, greater than, or equal to. Well, 23 squared is 529. 12 squared is 144, and 14 squared is 196. Gives us and 29 compared somehow to 340. How do they compare? Well, 340 is much less than 529. So we have the instance where c squared is greater than a squared plus b squared, which means our angle is greater than 90, making this an obtuse triangle. The next one, we start by checking to make sure it's a triangle at all. So without squaring the sides, take the two shorter ones and make sure that they're larger than that third side. Well, 5 plus 6 is only 11, not big enough for 14. So this one, we do no more work. It is not a triangle at all. Because again, in a triangle, two sides added together have to be longer than that third side, and that was not the case here. Here's our final one. So again, double check, make sure it's a triangle at all. Take the two smaller ones and add them together. Make sure they're bigger than that third side, which this is. 3 plus 4 is 7, which is greater than 5. Now let's use our testing skills to decide whether this is acute, obtuse, or right. So take the two smaller sides, the 3 and the 4, square them, and add them together. How do they compare to that longest side squared? Well, 5 squared is 25, 3 squared is 9, and 4 squared is 16. 9 plus 16 is 25. So how do they compare? They're equal. And when a squared plus b squared equals c squared, that is a right triangle.